Hi everyone, I'm just going to go over today's lab, but before I do that, I just want to give you a quick, make a quick request. When you are turning in your assignments to me, when you take a picture, if you take a picture like a selfie like this and hold the phone up and take your selfie, I can't read your paper. Sometimes you might even be covering it with your hand, but mostly it's really small. So what I want you to do is when you're going to turn in an assignment by taking a picture, look at this here. There's my assignment and it's on the table. Okay, so you can see it's on the table, and then take your camera and fill up the whole screen with the assignment. Okay, let's see, I get it so you guys can see it. There we go. Fill up the whole screen with paper. That way I can read the words. If you hold them way out like a selfie, I can't see what's going on. So please, when you turn in your assignments, take the picture of just the paper with nothing else extra. Okay? So now let's get started on our assignment. Okay, so we're going to start by putting our name on our paper. Always start with that. Period 1, 2, 3, 5, whichever one is yours. Okay, so we're going to use M&Ms to model atoms, and we're going to try and balance equations with those. I'm not going to spend too much time on the instructions. We'll just get right to it. So now I use Skittles, so I don't have all the colors that they're asking for. But I'm going to show you, I will draw the real colors, and then I'll put candies on there, and you'll see where there's a difference. So hydrogen, it says we should use brown, and we're going to start with an H2 atom. And then oxygen is blue, and then we've got an O2 atom, and we're going to finish with an H2O. And we're all getting pretty familiar with H2O now. So there's our H2O. Let's do it with candies now. Now I don't have brown, so I'm going to use reds for browns. And I don't have blue, so I'm going to use purples for blues. So now, if we start, what we want to do is we're going to take these reactants and turn them into products. So we have 2 hydrogens over here and 1 oxygen. So we are not balanced. If we go ahead and answer these questions down here at the bottom, we'll see we have 0 hydrogen candies left on the left side and 2 on the right. There's 1 oxygen on the left and 1 on the right. So we did not use up all of the oxygen. Matter cannot be created or destroyed, and we left this little oxygen guy behind. So he wasn't included in our end product, so he was kind of destroyed. So our equation is not balanced. We need to figure out a way to make it so that matter is neither created nor destroyed. All the atoms from the left must make it to the right. So let's clear these up, and we'll move to the next page. All right. So again, I'm going to start by drawing, and we've got sodium in the orange, 1 sodium, and chlorine is blue. So there's our sodium chloride molecule. We've got calcium, which is brown, and oxygen is green. Over here, we're going to end up with sodium, 2 sodiums, and an oxygen. And then we're going to end up with 1 calcium with 2 chlorines. Okay, so now let's use our candies to model that. So we've got, again, I don't have blue, so I'll use purple for blue. There's my sodium chloride. I don't have brown, so I'm going to use a red. And there's my calcium and oxygen. Over here, we've got 2 and 1 oxygen, and then 1 calcium and 2 chlorines. So we can see from the candies that they don't match up. We've got 1 sodium, 2 sodiums, 1 chlorine, 2 chlorines, 1 potassium, 1 potassium, 1 oxygen, 1 oxygen. So what we're going to do is if we need to get 2 chlorines. So the way to get 2 chlorines would be to add a 2 in front of this. Coefficient of 2. Now we'll have 2 chlorines, but we will also have another sodium. So we have to add an entire molecule, entire NaCl molecule, but that actually serves our purposes perfectly, because now we have 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, 1 calcium and 1 oxygen, 1 calcium and 1 oxygen. So this is our final equation. 2 NaCl plus CaO yields Na2O plus CaCl2. Okay, so that is reaction number 2. So we're going to clear these guys up. And we'll finish up with our drawing part as well. We had to add 1 sodium chloride, 1 salt molecule. Now we've got a balanced equation. Let's move on to number 3. We've got 1 potassium, which is red. A chlorine is blue. And 3 oxygens. And that's going to yield potassium and chlorine and some oxygen. We're good on potassium, 1 potassium, 1 potassium, 1 chlorine, 1 chlorine, but we have 3 oxygens and only 2 oxygens over here. So when we have a 3 and a 2, it's very difficult to match up an even number with an odd, so we're going to go ahead and multiply this side by 3. So now, instead of just 1 O2 molecule, we have 3 O2 molecules, which gives us 6 oxygen atoms. Now over here, we have 3 oxygen atoms. So if we want to turn 3 into 6, we're going to put a coefficient of 2 here. 2 times 3 will give us 6. So in order to do that, we're saying we have 2 KClO3 molecules. So we have to add that entire molecule to this side. So now let's take a look at what we've got. We do have our 6 oxygens now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But now we've got 1 potassium, 2 potassiums, only 1 over here. 1 chlorine, 2 chlorines, only 1 over here. But that seems like a quick fix for us. We'll put a 2 right there. And now we've got a balanced equation. So I'm not going to do it with the candies from here on out in interest of time, but you can do that with the candies if you like. And so our final equation is 2 KClO3 is going to yield 2 KCl plus 3 O2s. And now let's move on to the reaction number 4. We've got potassium, oxygen, and hydrogen. And then over here, we've got a sodium. So KOH plus sodium will yield an AOH, so a sodium, an oxygen, and a hydrogen. And then we've got potassium over there. So if we look at this, this is a really good example of a chemical reaction because we can see we're already balanced. We have one potassium, one sodium, one oxygen, one hydrogen, and all we did was we rearranged the atoms. So a chemical reaction rearranges the atoms. And in this case, the potassium and the sodium just kind of traded places. Here the sodium was by itself, the potassium was with OH, here the sodium's with OH, and potassium's by itself. So, easy peasy, our reaction is KOH plus Na yields NaOH plus K. So, continuing with balancing chemical equations, we have water. So we got 2 hydrogens and 1 oxygen. And then SO3 is 1 sulfur atom and 3 oxygens. So when we combine those yield H2SO4. So 2 H's again, 1 sulfur, and 4 oxygens. And even though that looks complicated, when we count them up, it looks like they're all balanced already for us. So 1, 2 hydrogens on the left, 1, 2 hydrogens on the right, 1 sulfur on the left, 1 sulfur on the right, 4 oxygens on the right, 1, 2, 3, 4 on the left. So we're balanced. So our correct equation is H2O plus SO3 yields H2SO4. Next one, 2 hydrogens, an H2 molecule, and then a bromine molecule, so 2 bromines, and those are going to yield an HBr molecule. So the left side of the arrow has 1, 2 hydrogens, the right side has only 1, left side has 1, 2 bromines, the right side has only 1. So in order to get 2 bromines on the right, we're going to put a coefficient of 2. And if we're adding a bromine, we have to add a hydrogen with it because we can only add full molecules. But now that helps us out all together. We've got 1, 2 hydrogens on the left, 1, 2 on the right, 2 bromines, 2 bromines. We're good to go. So our equation, our balanced equation, H2 plus Br2 yields HBr, 2 of those, 2 HBrs. Next, carbon, 1 carbon plus 2 plus a hydrogen molecule, which is H2, so 2 atoms of hydrogen. If we combine those will yield a CH4 molecule. 1 carbon 4 hydrogens. Now if we look on the right side, we have 1 carbon, we have 1 on the left, so we're happy there. But we've got, excuse me, we've got 4 hydrogens and only 2 hydrogens on this side. So if we add a coefficient of 2, we get to add another H2 molecule. And now we're good to go. 4 hydrogens, 4 hydrogens. So our final balanced equation, carbon plus 2 hydrogen molecules, 2 H2s, will yield CH4. All right, so now number 4, we've got 1 carbon and 2 oxygens in the form of 1 O2 molecule. So if we combine 1 carbon with an O2 molecule, it will yield 1 CO molecule. But that does not balance. So we've got carbons balanced, but we have 2 oxygens on the left and only 1 on the right. So we need to add a coefficient of 2. And now we have 2 CO molecules, which gives us 2 oxygens on the right side now. So those balance, but now our carbons don't balance. And we need to add a coefficient of 2 here. So we get 2 carbons, and now we're balanced. We have 2 carbons on the left, 2 carbons on the right, 2 oxygens on the left, 2 oxygens on the right. So our balanced equation is 2 carbon plus 1 O2 molecule yields 2 carbon monoxide. And the last one, H2O2, so 2 hydrogens, 2 oxygens will yield water, so 2 H's, 1 O, plus an O2 molecule. And again, we're not balanced. We've got 3, our hydrogens match, but we've got 3 oxygens on the right and only 2 on the left. So we're going to add another water molecule. Put 2, coefficient of 2 in front of the water, and then we'll get 1 more water molecule. So now we have 4 water molecules, 4 oxygen atoms on the right hand side, and we have 2 on the left. But now we can remedy that by putting a coefficient of 2 in front of the H2O2. So we'll get another H2O2 molecule. And now we have 4 hydrogens, 1, 2, 3, 4, and 4 on the right, 1, 2, 3, 4. 4 oxygens on the left and 4 oxygens on the right. So our final equation, balanced equation, is 2H2O2 plus 2H2O, 2H2O2 yields 2 H2Os, 2 waters, plus an O2 molecule. Up with these questions. So what did our candies represent in this lab? The candies, each candy was an atom. So we moved those atoms around to show that none were created or destroyed. We just kept moving them around. We always had as many atoms at the end as we started with. The coefficient is the number. It tells us the number of molecules in each component of the reaction. So the number of molecules. And what are the steps to balancing a chemical equation? So first, we're going to count each type of atom on both sides. Let me check. Is it balanced? And then we're going to adjust the coefficients. Easy for me to say. Try that again. Adjust the coefficients until they are balanced. And so now, how does the law of conservation of matter apply to chemical reactions? Atoms cannot be created or destroyed. So we must end with the same number of each type of atom. That we started with. All right, so now just a few more equations to balance, and we're good to go. So we start off, we're going to list all of the different elements that are on each side of this equation. So we've got zinc, hydrogen, and chlorine. Zinc, hydrogen, chlorine on the right. So we've got one zinc, one hydrogen, one chlorine. One zinc, one chlorine, and two hydrogens. So the first thing we need to do is make this 2. In order to get 2 hydrogens on this side, we need to add a coefficient of 2 right there. But that will also give us 2 chlorines. Oops. Two chlorines. So now we need to make 2 chlorines over here. How can we do that? We're going to add a coefficient of 2 right there. So 2, now we add another zinc. So we've got 2 zincs now, and we need to have 2 zincs on this side. In order to get 2 zinc on that side, we need to add a coefficient of 2. And now we're good to go. Our final equation, 2 zinc plus 2 hydrochloric acid will lead to 2 ZnCl's plus an H2. Next one, we've got K, which is potassium, N stands for nitrogen, and O is oxygen. Potassium, nitrogen, oxygen. Got 1 potassium, 1 nitrogen, and 3 oxygen. 1 potassium, 1 nitrogen. 2 oxygen plus 2 oxygen is 4 oxygen. So now we need to get our oxygens do not match. So first thing we're going to do is, it's hard when we have an odd number and an even number to match them up. So we want to try and turn this into an even number. We're going to put a 2 out in front here, and that gives us 2 Ks 2 potassiums now, and 2 nitrogens, and 6 oxygens. So now we have to come up here and we have to fix our potassiums and our nitrogens. So it goes, we're going to put a 2 in front of this, and we'll get 2 potassium, 2 nitrogen. And now let's check carefully our oxygen. We got 2 times 2, that gives us 4 oxygens for this molecule, and we have 2 oxygens with this molecule, so that's a total of 6, so we are balanced. So it's 2KN03 yields 2KNO2 plus O2 is our final balanced equation. And now, last but not least, number 3, we've got hydrogen, chlorine, calcium, carbon, and oxygen. So let's take a look here, make sure everybody understands how we found those. We have H, which is hydrogen, and then the Cl goes together, a capital and a lowercase. Here we have another capital and lowercase, so that's calcium, a capital by itself, and another capital by itself. So hydrogen, chlorine, calcium, carbon, oxygen. Okay? And we have the same on the other side. We have hydrogen, H by itself, chlorine, right there, calcium, carbon, and oxygen. Okay, so let's start counting. We have 1 hydrogen, 1 chlorine, 1 calcium, 1 carbon, 3 oxygens. Hydrogen, 2 hydrogens, 2 chlorines, 1 calcium, there's no subscript, 1 carbon, again no subscript, and 2 oxygens, plus another oxygen over here for 3 oxygens. So we're good on oxygen. We have the same number of carbons, the same number of calciums, but we need 2 chlorines and we need 2 hydrogens. So this needs to get bumped up to 2. And so we're going to have to go and put a subscript in front of this. That gives us 2 chlorines and 2 hydrogens. That solves all our problems. So we, oops, this is supposed to be a 2, another hydrogen. So a 2. So now we have 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygen, 3 oxygen. So we are good to go. And our final balanced equation is 2 HCl, hydrochloric acid, plus calcium carbonate will yield carbon dioxide, water, and calcium chloride. And there we go. You guys have a great day. See you next week.